welcome back. We're here for the second panel session, which is the industry panel session. So what we'll do is each panelist will present a brief 5-10 minute slide deck, and then we'll commence the more free-form panel discussions as we saw yesterday. So I would like to preserve as much time for the actual discussions, because I think, as we saw before the break, they were a bit more interesting for those in the room, probably those online as well. So I would ask that presenters do adhere to the time limit, and then we can save some more time for the interesting discussions to follow. So I know we've heard from PJ before, but this is the industry panel discussion presentation from Red. So PJ Muller.
Okay, so maybe very quickly.
Do you want to podium or?
Well,
So,
I don't necessarily. Yeah, so I'm Pierre-Jean Muller. I'm CEO of Red Technologies. I have been in this business for quite a while. Maybe two things important. I'm at the board of the Wireless Innovation Forum. So the Wireless Innovation Forum is the standard body for CBRS. Is also the standard body for AFC. So it's a place where spectrum sharing using database or dynamic spectrum sharing is quite interesting. And I'm also at the board of the NFR, so Emmanuel there. So I was quite critical to it while being at the board. So maybe I don't have a board seat anymore. Okay, Red Technologies. So I mean, we started as a startup, and we started really on license shared access, when really both on the US and in Europe, we were at the same time discussing this dynamic spectrum access. Means the fact is LSA never really come to anything. So we have to switch to US. So now I spend my time more in the US than in Europe, unfortunately. For the company, we are certified spectrum access system administrator, and we are also running TV white space in the US and in Canada. And we do a little bit of private 5G in Europe as well, especially in France. So that's it. That's it for me.
thank you very much. Next up is Ulrich Rehfuess from Nokia. Welcome, Ulrich.
Yeah, thank you very much for having me here. Well, looking at our host here, looking at the list of bands that had been proposed for the sharing discussion here, I thought I focus my minutes here on the 470 to 694 megahertz range. So probably, as everyone's aware, there had been big discussions on region 1 leading into WRC, and the result now giving a secondary mobile allocation across the full band for 7694 megahertz to most of CPT, so with the exception of Spain and Italy. A primary mobile allocation in the 600 megahertz range for these dark blue ASMG countries, who are actually now moving forward, or some of them moving forward on that. And a secondary mobile allocation in that more light blue in some African countries in the 600 megahertz range. There also had been some extended footnotes for countries in other regions. So there's always also agenda item 8 to watch on certain changes. So what does that mean from the spectrum bars, let's say? So certainly there is this band N71 deployed in the US and looked into in North America further. And that would nicely fit and sit under the 700 megahertz allocations globally. There also is a band definition N108, which hypothetically applies globally in broadcast spectrum for broadcast purposes, for 5G broadcast purposes to be precise, having 8, 7, and 6 megahertz channel bandwidths, thus fitting into the existing broadcast rasters. And then overlapping at the top end with the band 71. So we're talking sharing. And maybe one statement, also sharing for 7694 is possible. I think the PMSE industry would fully agree that they can share. Also, we as mobile industry, in cooperation and collaboration with broadcast industry, tried some sharing in the past. So in the 700 megahertz band, when it was still fully used for broadcast in Europe. So one example here is from Munich, where with Bavarian Broadcasting Corporation and then still existing IRT, we had an EMBMS FDD deployment even in a pretty packed 700 megahertz band. So you see a number of multiplexes in the band, and how we were lucky to fit that fixed pair of FDD into that. Uplink caused some headaches, to be frank, and that's maybe not what we typically would recommend, but downlink didn't cause much issues. In Finland, we did a trial then using supplemental downlink, so carrier aggregation of band 7, which is a 2.6 gigahertz FDD, where Nokia had a test license in Finland, or at least in the area, with a band 28 10 megahertz channel. So again, lucky to have maybe two adjacent 8 megahertz channel that could host that 10 megahertz channel, and then basically demonstrating, well, it doesn't affect DTT, but we could double up the downlink capacity of an FDD system with UHF spectrum. So it's a bit of the question not if, but how sharing can be done. So key issue is really protecting the mobile uplink, and which typically in the past has led to these complete clearance of a region, so that then FDD could be deployed. The reason is just you have 20, 30 meter high base station antenna seeing line of sight, maybe even a 200 kilometer far away DTT tower with 100 megawatts. So that's really the big challenge. So let's say if it's really within the country, an FDD operation, probably one stays with that clearing criterion, and I guess that's what happens in like Saudi Arabia or UAE when they introduce it. Nevertheless, you have to consider border constraints, you have Geneva 06 rights, and so on and so forth. But then I think there's a big difference between the downlink range and the uplink range. So in the uplink range, preferably, you would need to see if you can negotiate something, maybe trade certain other usage rights whatsoever. But downlink, let's say typically a base station in one country would not significantly interfere typically across the border, and you can do a lot in terms of network engineering to also mitigate that further. Plus, you can exercise existing Geneva 06 rights and so forth. So I've also pointed here to a study of TMG who on a very high level discuss such options. Probably it requires larger geographies than some of the European country borders that we have, and it certainly requires certain coordination across borders, but still there could be sharing and coexistence possible between countries with continued DTT operation, maybe modestly impacted on a very countable number of transmitters, and other countries moving forward. And there's even precedents. So we have regional borders like Finland with Russia, where in 700 megahertz there's some experience. So listing possible sharing options. So as said, the mobile uplink sharing with DTT is a difficult one. Mobile downlink sharing with DTT should be much easier. Mobile uplink and downlink sharing with PMSE. So typically, well, unless you water fill the entire spectrum, certainly with IMT, but given you have a certain spectrum management by the regulator, a DTT carrier should be more harmful to PMSE than a much lower power mobile carrier. Well, certainly you need to look at the exact scenarios and so forth, but in principle it would be very similar. Certainly uplink in the band when it comes very close and maybe even indoors to where the PMSE installation is then maybe the more critical part. But then looking at the other incumbents discussed a lot, for instance, in PTD, like wind profile, radios, radio astronomy, you could treat them probably very much like you treat DTT carriers today in terms of assignments. So the basic idea, what do we do with spectrum below the 600 megahertz range? So there, I think something like this band N108 would offer opportunities to consider additional downlink use. in combination or eventually replacing the terrestrial DTT, DVB-T with 5G broadcast and certain mobile use. Mobile use could be supplemental downlink, could also be new band combinations where typically at the moment, for instance, there are band combinations that use a sub 1 gigahertz uplink together with L-band in an FDD manner. So that's less complexity implementation wise and has some other advantages over carrier aggregation. So don't take SDL too literally there. It could be also an FDD combination yet to be defined. So with this, some ideas on UHF, and then looking forward to the panel discussion, probably being a bit wider on more bands. Thank you.
Thank you very much. Just remind myself, actually, it's Reza from Huawei. Yep.
Spacebar, was that?
Yes.
Well, good morning. Pleasure to be here, and many thanks to Winform for inviting me to say a few words on spectrum sharing. So let me start by some broad discussions on spectrum sharing. There's a growing demand for, still growing demand for terrestrial mobile broadband, and it's understood that replanning and clearing bands for mobile networks is not going to be always possible. So I think there's general consensus and agreement that increasing levels of spectrum sharing between mobile networks and other users of spectrum is inevitable going forward. And frankly, the mobile industry has been active in developing sharing mechanisms with other services at a global level. I mean, an example was at WRC-23, where we were looking at actually upper 6 gigahertz and sharing with satellite uplink. And the mobile industry developed a new metric for measuring radiations above the horizon from active antenna systems in order to protect satellites. So nevertheless, in terms of spectrum sharing, it's not always very easy. It's rarely a simple thing to do. So we should really pick the right cases for sharing. And we should look at sharing cases where there's not undue degradation in performance or high costs of the users, which would result in overstringent technical conditions. Because if this technical conditions are overstringent, this will disincentivize people from investing. And also the frameworks shouldn't be too complex, and they should avoid uncertainty of access to the spectrum. So are there any guidelines, broad guidelines we can look at in terms of applying spectrum sharing? Firstly, I think spectrum sharing should not be viewed as an end to itself. I know a lot of folks may have different views, and spectrum sharing is specified as a policy target. I'm not sure that's the most helpful approach. Spectrum sharing should just be a tool to achieve specific policy objectives. And also the need for spectrum sharing should be examined on a case-by-case basis. And it should be contrasted and compared with alternative options. And these options should be all about addressing specific policy targets. And they should account for technical, economic, and social factors, and as well as opportunity costs. Unless we know what the policy objectives are, how can we know whether sharing provides net benefits over the band being used by one system or the other? Then maybe this is a bit obvious. So the role of space and time, geographic location and time in sharing. In terms of geographic separation, it's obvious where the distance between the interferent victim is large, then that simplifies sharing. And also it's useful if the victim is not ubiquitous in location, because if it is, then it's harder to protect it. And also it's useful if the victim's location is fixed, or more preferably fixed and known, because again, that can allow more simple sharing. And in terms of time, again, it would be useful if if you like, the time footprint or the usage patterns in time of the two sharing systems are dissimilar, so that could be exploited in terms of sharing between the two systems. But the short of it is, if we have similar footprints in geography and time between two systems, then efficient sharing is always going to be challenging and very difficult. And that brings me to our favorite topic of IoT and Wi-Fi at the upper 6 gigahertz. Now, as you may know, there is a work item at CEPT looking at co-channel operation between what CEPT calls MFCN, which is mobile communication networks, and RLANs, which is essentially what Wi-Fi uses. So this table is meant to summarize, if you like, what's being looked at and what's being analyzed. And here we have scenarios 1 and 2, which look at full power mobile networks, full power MFCN, outdoor and indoor. And scenario 1 looks at the case where there are no mitigation mechanisms. And the broad consensus here is that without any mitigation mechanisms, then MFCNs and RLANs cannot operate co-channel at the same time and in the same geographic area. And maybe this is a bit obvious, but I think it was good to have some technical analysis to show this. So you need some mitigation mechanisms in order to allow the two systems to coexist. And scenario 2 looks at a number of mechanisms, which I'll explain in the following slides a bit more about. But then maybe more interestingly, we can go to the second column. Here is where the idea is to reduce the base station power from in the mobile networks. The idea being that by having lower power base stations, the interference to Wi-Fi can be reduced. But this doesn't necessarily solve in case of interference from UEs, mobile UEs to Wi-Fi, or indeed from Wi-Fi to MFCNs. And in any case, this approach of reducing the power of the base stations is not really aligned with the intentions of the mobile industry. The mobile industry wants to use this band to reuse the macrocellular base station grid in C-band to provide mobile coverage. If you reduce the power, then that becomes problematic. So it's not really a preferred solution for the mobile industry to reduce powers, because then we're talking about small cells rather than macrocellular deployments. So what are these mechanisms that we're looking at CEPT? And at the moment, we're looking at assessing them against criteria such as performance, hardware, software complexity, energy consumption, standardization, and regulatory harmonization. And this work is meant to be completed in January. So the report will go for public consultation. And the techniques that are being looked at basically fall under 2 broad categories. Sharing between Wi-Fi and IMT based on sensing-based solutions versus database or server-based solutions, which we've talked about quite a bit in this workshop. So let's look at the sensing-based solutions first. So in terms of sensing, there are 2 categories. One is where MFCN, that is mobile, senses RLAN, and then techniques where RLAN senses MFCN. And this is easier, of course, because MFCN mobile networks are higher power, so it's easier to sense them. So how do we have RLANs sense mobile networks? Well, one approach is that RLANs detect and decode some pilot signals that are transmitted by the base stations. These pilot signals can be either IMT-based pilot signals, or they can be Wi-Fi-based pilot signals. That is, Wi-Fi signals being transmitted by IMT base stations. Those are 2 options. Another option is to have smartphones actually detecting the presence of mobile and act as essentially distributed sensors. And we have the mirror example of that, where smartphones actually detect RLANs in terms of sensing, distributed sensing. And for all these solutions, then there are implications. Okay, one system's detected the other, what actions are taken? Well, generally it's either RLAN or mobile vacating the band, or maybe some other sharing in time and frequency. So this was the sensing-based solutions under investigation. In terms of database and server-based solutions, personally, I'm a great fan of database solutions because I think they can be more, shall we say, certain in terms of their operation, whereas to me, sensing can be a bit problematic or uncertain. And again, the example is that you'd have a database which has information about the mobile network deployment, and then when RLAN equipment want to transmit, they query the database, they provide location and parameters to the database, and the database tells them at what power and what characteristics and what channels and what bandwidths they can operate. And this can be static or dynamic, and it could be used to provide geographic sharing, sharing in time, or sharing in frequency, or a combination of all three. And this is my last slide. Takeaways. But we think in general, spectrum sharing between two systems should be considered only where there's a net benefit compared to where either one or the other system uses the band. And this, we think, requires a clear understanding of national connectivity policy targets. Without knowing what data rates we need to be delivered, for example, indoor or outdoor, it's very hard to judge whether the two systems need the band, and if they do, how sharing should happen. And for any successful outcome, we think a sharing framework should not introduce undue complexity, uncertainty, or inefficiency in the operation of the sharing systems. And this is very important in terms of incentives for investment. And of course, opportunities for efficient sharing are greatest when there's geographical or temporal footprints that are suitably different, and sharing doesn't really materially impact these footprints. And for this reason, there's a general preference for inter-service sharing. By service, we mean in the ITU, where typically these footprints can be different. It's much more challenging when we look at the technology sharing between IMT and Wi-Fi, which are both considered part of the same mobile service. And with that, I thank you for your attention and look forward to questions during the panel. Thank you.
Simon, just to mix things up a bit. Simon Eley from the BBC.
Spacebar to go on.
Yes.
Go back.
Back arrow to back, spacebar forward.
Great, thank you. I've spoken to many of you already on this event, which I've very much enjoyed. But just to say a little bit more about me, I am the technical specialist in the BBC looking after PMC. That's both operational, so I've had a call in the break about how long is my 200 megahertz whip going to be. I think I can work that out quite quickly compared to coming to events like this and representing BBC's spectrum interests, particularly around PMSE. I don't quite go back as far as 40 years and the Starlight Express. I came into PMSE just after that, when there was a organisation called ASP, which looked after independent spectrum management. And I was in the radio agency around the time that the PMC review took place and a new spectrum manager was brought in, which aggregated all PMSE spectrum and contracted out to a third-party provider to coordinate spectrum and sharing. And that has been, I think, very successful. In subsequent years, after some time being involved in that decision, I came back and actually worked for the organisation for a number of years on behalf of Ofcom, who were the customer. And that involved databases, that involved compatibility analysis, it involved spectrum sharing around with MOD, for example, whilst Cambridge have shared very successfully with MOD space services and the like. And so that was my role there. I have then spent a bit of time planning DTT as well in between, but I've come on to BBC where I use that experience together to protect to the benefit of the BBC. Now, we've heard from Tomo, we've heard from Duncan about PMSC industry in detail. I won't go over that. I looked over the agenda and figured that was what I predicted correctly. They would cover those areas. I won't be going over those again. And obviously hearing from John about handling of the major events. I've managed some big events, but not as big as John has managed as well. So I have that experience around spectrum sharing and planning big events. So I'm going to bring a particular subject, I think, which hopefully is more than just PMSC and hopefully will be useful for all sectors or something to consider maybe, particularly with regulators with us today. So if we consider broadcasting, BBC interest obviously in broadcasting, we have terrestrial and satellite assignments ranging from LF all the way up to 30 gigahertz, and terrestrial services, satellite services. And that's a primary service with the ITU, primary services. And way back over 100 years ago, so-called chaos in the ether led to the effective worldwide regulation that we have to this day, and organizations set up. Back then it was just the military and the broadcasters pretty much using the radio spectrum. So those were those mechanisms set up, and they've served us well through to the ITU today. So fix in your head, this is coordination and sharing through governments, through regulators, and that has served us well. Well, it's worked. And then I want to draw the parallels with the use of spectrum by program making and special events, which is well described already. I don't need to go into detail about that, but it's spectrum. Certainly in the UK, we have PMC spectrum bands running from 48 megahertz to 48 gigahertz. So many applications through Crofton wireless cameras, audio PMC, NIPS links, narrowband talkback, wideband talkback, and the like. So the key to that is virtually all of those ranges are secondary. And for secondary, we can say shared. And as I say, those key ranges, 470, 694, we've discussed a lot, the DME bands, 960, 1164, wireless camera ranges, around about 2 gigs as well, which are very important to those production, and the sorts of values and the sorts of value to economies has been well explained already. So how about the coordination and sharing of PMSE? Well, through government controlled regulators. Well, I put a question mark there because it's secondary and it's shared. Now, there are issues around the PMSE sector, which and its spectrum requirements, which aren't always well understood. The PMSE industry is relatively small compared to other sectors, the mobile industry particularly, and has little influence to counter or to exist alongside in other larger radio sectors. Now, PMSE does use mass market technologies and commercial off-the-shelf tech equipment and spectrum. DECT and 5G are big examples there. A lot of my time is spent trying to promote 5G private networks. We've had a few good examples of that around use of the Coronation, where we set up a 5G private network on the MAL, where we supported 30, 40 news gatherers, because we knew the public networks would be contended. We could use bonded SIM devices, very successful. We've used it at the Commonwealth Games in Birmingham, and most recently in Northern Ireland, supporting a sporting event in a rural area, a road race event where there was not connectivity. We could provide connectivity for multiple cameras in places around the course which they didn't previously have. And given that a lot of the other connected cameras in the rest of the outside broadcast were on 4G and fell over when the crowds turned up, they were very grateful for us in the end. So we use the mass market technologies and COTS equipment where we can, but those bespoke requirements remain. So ultra low latency applications for audio. We're seeing new products just outside here. We're seeing a low latency digital IEM. That's the first I've seen of that until now. We've been using analog FM because there's been nothing suitable for the relatively small sector that is PMC and the relatively smaller sector, which is in-ear monitoring. But the technology is coming along now. And the classic case that you may or may not be aware of is the artist singing on stage using a wireless microphone and having a wireless in-ear. And the path time to get back to the ear needs to be sub 4 milliseconds or so, that typically, because otherwise, contrasting with the bone conduction, it'll throw them off, and that has to be achieved. And so that's a particular requirement which has driven bespoke equipment to date. We need frequency bands with good propagation related to the antenna size and also low power consumption in portable devices. So that constrains PMC in terms of the frequency bands that we want to use and share, and determines who we share with. And we also need short notice access to sufficient suitable spectrum anywhere. That was a point I made yesterday, probably a bit forcefully, but it is tricky to get spectrum at short notice where we want to go, anywhere. A news provider, an outside broadcast provider. Who would have thought we'd have a massive spectrum demand in the middle of a field in Somerset, a rural part of England? It's called Glastonbury every, well, most years. And having coordinated that back in the day, it was a tricky event. So,
can you please go back to the?
Yeah, certainly.
Reza is making a comment on the first bullet point here. I don't think that's true. I think, as you said, broadcasters, if you have the broadcasters, the content creation, people like John, everyone get together and rally. I don't think when, the industry is small. I think we have a big, set of users. It's just that we're not in an alliance. We are not making our voice heard like the satellite industry or a mobile industry does. So I don't necessarily, again, that's also why I wanted to have this event here, and what we're doing around the globe is just trying to get people to recognize the needs.
Yeah. It's not a criticism. I fully take that. Yes.
Yeah, I think,
it's not a criticism.
We have a lot of
users.
users. We just need to, like speak one voice and just make ourselves better heard than before. So anyway.
Yes, I fully take that. It's a lot of small areas that need
it's
to
not.
be
Broadcasters are huge. NFL, Super Bowl. If you get the NFL in front of the FCC, I can tell you that the chairwoman listened to them, correct? So we just need to make sure we get the right people and we speak a same voice. I mean, that's what Verizon, AT&T does, do through DIA. You have GSMA. I think our industry, unfortunately, for many, many years, and that's what I think need to change, correct?
Yes, no, it's not a criticism. It's historically been the case. I think it's getting better. Yes. So what are the barriers to PMC spectrum sharing? I think these points aren't well understood by all regulators. Hopefully we can help put that right today. It's a shame Ofcom haven't come back today. There's little appreciation of the economic and cultural value of PMC. Tomo put some figures to it. I think it's very difficult to put figures together. I think it's even bigger. And the other comments around PMC is ubiquitous. It's very difficult to quantify that and make a case for that sometimes. And international efforts to promote PMC spectrum can lack a common focus. This is not to underestimate what Shure does. It's a lot of small people, small organizations, often doing the operational job without the time to lobby. But we have Berg in this country. We have the APW, help me out here.
APWPT.
in Germany, but it would do well to have more influence. We need more effort and more promotion there. That would certainly help. So I'll put something out there for you in terms of a way forward to promote more PMSE sharing. I started with broadcasting, which has successfully maintained and coordinated its spectrum through a common international understanding of its value from the outset of broadcasting. The distributing of broadcasting content is relying less on its own spectrum now as time goes on. We're moving to streaming, content delivery over telco networks, and talk of the end of DTT. So having lost, well, with DTT and the number of multiplexes, discussions going on in all countries, some are already switching off. Is it time to consider content production and PMSE spectrum as more than secondary to enhance sharing possibilities? The old primary, secondary, maybe it's had its day, particularly if we're looking at more sharing. As I mentioned, there has to be net benefit. We can show the benefit with PMSE. I think work in ITU, work in CPT, work in the other, I'm less familiar with the global. That needs to happen. And I see Shure are very much involved in that, and hopefully regulators and those wishing to share can approach this with a more level playing field.
Again, I cannot resist. So I don't necessarily think that we'll be able to change the discussion about primary and secondary. I think, like 190 countries in ITU, and I think that's just going to be there. I think the language need to change to we are an incumbent. PMSE is an incumbent in the band, just like TV is. I think, you need to start with that premise. We're incumbent, so we've been there for decades, and we need to continue to get access to us. I think the second bullet point is interesting, correct? Because if you look at the US, situation, we have incentive auction in 2017, and now we are hearing about potentially another auction. And some of the drivers is actually broadcasters going around, that's what I heard, saying that, as you said, correct, content is moving to a distribution mechanism, so they may not need spectrum, so they're willing to sell that spectrum. And obviously, if you go to T-Mobile, Verizon, and AT&T and say you want to sell, they're like, okay, I'll buy it, correct? So, and then you have STC in middle, say, okay, let's do another incentive auction to Dutch. That's what is going on in the US. The question then is, I wanted actually to hear more about the future of broadcasting rather than PMSE, because I think you've heard enough about PMSE. Is the future of broadcasting really streaming and other stuff? Like we've seen an article from the CEO of BBC, for example, talking about we're going to just turn off all the, the stations at some point, because that's also driving what's going on with that spectrum, correct? Because if they give a spectrum or sell the spectrum to mobile operators, what's going on then is the spectrum for PMSE has just been increasing as a result of that, correct? So if we have another incentive auction in the US, PMSE are going to lose spectrum again. And it's not necessarily been driven by mobile operators. Sometimes the broadcasters not being coherent in terms of the future and in terms of what we want to do with that spectrum. I think I wanted to hear more about that rather than PMSE, because I think we've heard enough about PMSE. So yeah, I don't know if you have any comments on that. So do you think?
I hope to be provocative. I think I've achieved that.
No, because the thing about PMSE and stuff, we've had. I really wanted to hear more about broadcasters and the future of broadcasters, because that's really impacting PMSE.
I can't share anything on that because decisions haven't been made.
Okay.
Can I just say that from Paris this year, the BBC had broke out streaming records, 218 million. NBC streaming records from Tokyo to Paris this year went through the roof. We've not got the full figures yet, but they're actually saying they broke every streaming record there was that they could find in the world because of the sheer content, because the on-demand services mean, Discovery stole the rights away for you guys for a chunk of it, but their streaming platform was so cheap to register to for £69 for a year, but they streamed every live event, and that's what they're finding now. The demand for streaming is now overtaking the terrestrial side,
That's right.
and that's the way it's going to continue, and everything, and that's why the Paralympics this time was the first time ever every sport was live. They've never done that before because the streaming side was where the demand was.
Take that on board entirely.
Yeah.
BBC has a public service requirement, and we need to maintain a service for those that do not take advantage of streaming
Yeah.
until the
But
very
how much
last.
spectrum do you need at the end, correct? So I guess my counter argument to what's going on in the US right now about this incentive auction 2.0 is, you know, if broadcasters want to sell their spectrum or part of it, then they need to move below 470 megahertz, or they don't repark and just turn off to free up spectrum for PMSC. Because what has been happening is they got $10 billion, correct, from incentive auction, and they still got access to spectrum, but just move and repark below. And PMSC spectrum available to PMSC has been disappearing. And I think, and I think at some point there need to be like, if you don't need spectrum, you get $10 billion and you get out of the spectrum, correct? You cannot get $10 billion and you just get access to spectrum, but basically you got for free. And you know, so there's in US right now, it's a, you know, that's becoming a reality more and more. It's like another auction. I mean, for us, losing another 84 megahertz of spectrum out of 140 left. We have like 2 channels, I think, in Phoenix, where we did the Super Bowl. And if another such auction happened at 500 megahertz, and then, you know, TV is reparked in the bottom, those 2 channels. So how do we do all these events? I think it's more than just the PMS industry. I think all of these users need to get together and figure out really the story, right? Including broadcasters. I can tell you, when I talk to broadcasters in US, you have BBC, I mean, NBC, all these big guys say we want spectrum. Smaller players are like, you know, I want to become millionaire overnight. Let me sell it for, you know, $1 million to T-Mobile and, you know, and retire.
I think NBC will go. Again, I'll just give you a fact and a figure because I was in one of the meetings. NBC streamed with their Peacock network
I fully accept that streaming is
23.5 billion minutes.
Yes.
That's where it's all going, because one of the things that was published a few years ago, everybody's like, oh, the terrestrial, nobody's interested in these big events because the TV viewership. But the idiots who wrote into the facts and figures, yes, the TV viewership's down. The streaming figures are through the roof.
I return to my point before.
Yeah.
We have a public service commitment to those who don't take up streaming.
Yeah.
Anyway, interesting. So
Perhaps that's a key
Therefore,
difference.
that is what is, those are the date, that's what's pushing back any time before we move it out.
Could we save any questions? Because there are some more presentations to get through and I want to be even handed. So I think you're next up.
Streaming is just
This is a little bit, we're going to mix it up now. There you go.
Hi everyone, my name is Gökhan. I work in Access Partnership. It's a technology policy consultancy based in London, and I hope to bring a different flavor to this conversation with satellites and smartphones. So I have a couple of annex slides that actually I want to start with them because I realized that maybe we should start with the basics. So our interest in direct-to-device topic started like 2.5 years ago when we published this white paper called The Future of Smartphones. At that time, we called it direct-to-handset, but the paper was named as Future of Smartphones. Right now, I'm trying to distance myself a little bit from that word smartphone because actually direct-to-device can be done with any phone that uses 4G, and that would also include feature phones or dumb phones, which are not smart, but available in the market for elderly people or people who are trying to fight with their social media addiction, for instance. So the concept is very basic. We will have a mobile handset, and that will be able to speak to the satellites. So normally, satellite phones and mobile phones used to be two different areas. And the satellite phones used to have like bulky antennas, and most of the time they are proprietary technologies that works with only one constellation. So they developed and they lived in adjacent markets separately for some decades. But right now we see some convergence. They are getting together, and that's interesting because we don't know how the markets and regulations will evolve. But normally this is the value chain. We would start with the standards, and then the manufacturers, they would produce the chips and antennas, and then we would have the connectivity providers. That could be a mobile operator or a satellite operator. I'm going to discuss two different deployment models for direct-to-device in a couple of minutes, and you will see that they both have some roles to play. And then it would go to applications and policymakers and regulators. And why we need this? So there are two very important things that direct-to-device can help us. The first is when there is an emergency in a stranded mountainside or in a desert, etc., where mobile coverage is not available. This can help saving lives. In the first deployment examples, we see that Apple, with their partnership through Globalstar, is using this in 15 or 16 countries right now for emergency SOS via satellite. This is how they call their service. And there are interesting use cases where after a car crash in a valley in USA, people were only able to call 911 through this service, etc. And the second thing is the disaster situations. When the terrestrial networks are down, the satellite communications always gave some kind of resilience to us. But traditionally, this used to be with emergency responders. They used to use satellite phones and satellite terminals to communicate right after the disasters. Right now, we see that with direct-to-device, general public might also be able to use satellite communications for communicate between each other, but more importantly, to get the emergency messages from public safety officials. An interesting example, real-life use case happened just like a month ago during the Hurricane Milton and Helen in the USA. FCC gave a special temporary authority to Starlink to use, I think, 10 megahertz of T-Mobile spectrum in the disaster-affected areas. So I mentioned that there are two different cases for direct-to-device. So this actually comes from technological needs, first of all. So this is an iPhone 14. So this phone connects to the satellite, and actually this is the reason I bought this one. So normally there would be an antenna here. So in this proprietary technology, they managed to put the antenna inside, so there is not much change in the form factor. And Apple uses Globalstar network, so it's an MSS spectrum. And so we can actually say that theoretically this one is also a satellite phone. In some other examples, instead of changing the mobile handset, because there are like millions of mobile handsets already in the market, some satellite communications providers are changing their satellites to communicate with the mobile handset. These are Starlink, AST Space Mobile, and Link are the three prominent examples of this model. And their goal is to reach out to the conventional mobile handset which you or any of us have. So in terms of the deployment models, generally we call them MSS model and MS model, or sometimes instead of MS model, you can see this as IMT, direct to device IMT, or satellite to cell IMT model. So in the first one, if you have a handset with a better antenna and a chipset, I don't call it modified, but because it creates another set of questions. Let's say that advanced antenna and chipset, you can use the MSS spectrum, and this is already ready to be used. It is already allocated. If you have the licenses, you are good to go. But in terms of the disadvantages, you would have a limited bandwidth, limited capacity, and you might need upgrades in terms of hardware and software in the device. So, for instance, this one with the chipset and the antenna suitable for MSS spectrum, iPhone 14, but iPhone 12 or 13 would not be able to use this technology. So on the other side, we have the MS model, where the mobile spectrum will be used with direct-to-device. And this could be any phone that can connect to the 4G networks. So existing devices can use, which is a huge plus in terms of the market deployment. And they say that they can provide more capacity. But in terms of the regulatory side of the things, we don't know how this will be managed in terms of cross-border interference, in terms of sharing this at the same time with the mobile services. And in terms of the deployment, we do not see any real-life prolonged examples of this yet. So, but as I said, there are emergency use cases and regulatory sandboxes in some countries, as I'm going to mention right now. So, there is an agenda item in WRC-27 agenda on this issue, 1.13. It looks at the IMT spectrum. If we go to this, we generally, if we go back to this for a second, we generally say that in MSS model, it's good to go. But in the MS model, if we are going to use the IMT bands, there needs to be more studies. So there is an agenda item in WRC-27, 1.13, and they are looking at sharing and coexistence compatibility scenarios for satellite and IMT in IMT bands, satellite and mobile industry in IMT bands. But we also see that in some jurisdictions, there are already some regulatory activities. The most famous one is the FCC, Supplemental Coverage from Space framework. So Canada is following the SES example. So at least in North America, it seems like there will be some kind of harmonization in that sense. So they are adding secondary MSS allocation to IMT bands between 694 to 2700 megahertz. And if a satellite operator gets into an agreement with a mobile operator, they will be able to lease or share the mobile IMT bands for the direct-to-device. In Brazil, they developed a regulatory sandbox, which is like an extended example of a test permit. And currently, AST Space Mobile is doing tests with 2 different mobile operators for 2.5 years. In Australia, the regulator published their opinion on direct-to-device, which we take as a light touch on this topic, because what they said is on MSS, everyone is good to go. On MS, you are good to go. If there's an interference, let's talk and try to solve this. So it's like a quite chilled take on direct-to-device. In Ghana, there is an interesting example. In Ghana, they are trying to develop a rural common network, and the mobile operators are obliged to enter into roaming agreements with each other. So they are embedding direct-to-device into this rural network called Ruracom. And if any mobile operator needs to, if any mobile operator would like to integrate satellite services into their offer, they need to do this through Ruracom. So in a sense, this would include everyone. So it would be more inclusive rather than a competitive edge for a mobile operator. So I'm gonna stop here just by mentioning one more thing. At the beginning of the presentation, I said that Apple started this service with emergency SOS via satellite with Globalstar. I think around like 45 minutes ago, they announced that they are creating a new constellation with a 1.5 billion investment. So probably it will be more than text messages, and it will be more than 16 countries in the past, in the future. So it is an interesting market in satellite communications. I think this is one of the biggest developments that everyone is talking about, and probably on our side of things, on the satellite part of the spectrum world, we will continue to speak about this even more. Thank you.
And well, just a note on timings.
I'll be very quick.
Thank you. I will start waving at you.
Is it the space bar?
Yes.
So I'm just going to be really quick. And my name is Manuel Marti. I'm a spectrum policy consultant for LS Telcom. LS Telcom is a licensing software provider, but we also have other divisions where we do hardware and spectrum monitoring, and I'm part of the spectrum consultant division. And what I wanted to talk to you about today is I wanted to start with a little story when I first joined the industry that some of you might be able to relate with. I do have a background on media and international relations, and I do remember that one of the very first conferences I went to back in 2017, 2018, someone said a quote that I still remember today, that it goes by, everybody's willing to share a spectrum until it's their own spectrum. And I think that to some extent is still present today. I mean, I think that things have evolved. We've seen CBRS. I mean, I think that everybody today, we've heard quite a few learnings from CBRS. We heard yesterday from Ofcom about the different shared access licenses that they have implemented. But I think there's a lot of room for improvement and to progress. So what I wanted to talk to you today is about some of the key messages that we recently did a study for the UK Spectrum Policy Forum. And I think that what the study tried to do is try to look at some of the potential barriers and also look at some of potential scenarios for sharing between civilian and military, which I suspect is going to be quite a hot topic over the next couple of years. And we heard from James yesterday that the MOD does share a spectrum, and I think it did say something around 85% of their spectrum. I think not of that is shared with civilians, but I think there is some spectrum sharing between civilian and military happening in the UK at the minute. However, that is suboptimal, and I think that's constrained as well. As I said, this study tried to determine some of the key barriers and potential options for a future where there's going to be sharing in some of those harder to access bands and some of those more complex sharing scenarios. And I think that having that framework that enables that sharing is going to be key going forward. And here are some of the key messages. I mean, this is a bit of a mix between findings, recommendations, and so on. But I think that if we want sharing to take a more prominent role, I think first it's important to look at a spectrum demand. what is that demand for that shared spectrum? And I think that we often think about MNOs having a lot of demand, but I think there's other uses out there. So I think that PMC seems to have proven that there is demand for PMC, and it seems to work fairly well with the sharing with the military in the past. There's some other use cases and users, whether it's the satellite IoT and others. So I think it's important to look at demand. And then, of course, there's going to be some technical and operational barriers. I think that the nature of military and civilian use and requirements are fairly different. I think that we heard yesterday about some of the requirements and prerequisites and considerations that the military needs to have in order to have some sort of sharing with civilians. I think that obfuscation when it comes to the spectrum, having that spectrum back whenever they require, I think it's really important for them to have that trust. And I think talking about trust, I think there's also non-technical barriers that need to be addressed. I think that the flow of information, the relationship between that, and also I think we've heard about over the last 2 days on the evolution, how CBRS started really conservative and now is moving. So I think it's all about building the trust that also needs to be key. But I think let's not forget that the availability of a spectrum for commercial users needs to be there, and the certainty around that availability. I think that Reza touched upon earlier. And I think that without that certainty, not many commercial users will be able to build a commercial case around it. And perhaps if we move to the right-hand side, I think that international harmonization, not only when it comes to the standards, but also in terms of the sharing approaches, I think that there needs to be more harmonization across Europe, but also across the world. And I think the final point that I wanted to mention is that civilian users do fairly well in predicting and having some sort of roadmap on future spectrum use. The military users don't do that so well. So I think that having that predictability, having that transparency, having that roadmap on the future on what potential frequency bands might be using in the future, it's going to help. And then if we look specifically into some of the agenda items for the next conference, we do see some agenda items for potential IMT identifications under agenda item 1.7 is that they are NATO harmonized bands. So is there a need for NATO to have a more comprehensive and more cohesive approach to that? And I think if some of these factors come together, I think it is possible where more access to shared spectrum in those more difficult scenarios, in those more difficult bands, would actually be able to take place. So I'm going to end it here, and then obviously happy to take questions at the end of the panel. Thank you.
It should be next. Oh. Francisco. Welcome, Francisco.
Oh, hi, everybody. I'm the satellite guy, one of the satellite guys. So this has nothing to do that what we've been seeing the last 2 days. Of course, it always says 31st of October. It's first, but whatever. So it doesn't really matter the gender. But basically, I'm going to be talking about the physical sharing between satellites, and just a small topic on the spectrum sharing of agenda item 1 and 2 in WRC. I'm going to try to be as brief as possible. So right now, the current situation, how we ended up as we are right now, we come from the past decades from a geostationary dominated space environment, and now it's leaning towards a multi-orbit dominated one, currently like in the low Earth orbit. Why? It's easier to reach, so you need less propellant, it's cheaper. The platforms, because you just don't have a huge one, you have like smaller ones, so they're much cheaper to get them. Then it's a more complex environment because you need to do lots of handovers. You don't have the same visibility on with one satellite in the same place. And so it's a much faster paced context, commercially, technically, and physically. So the importance of space traffic management is crucial, not only when you're in service, when it's the altitude that you're actually like providing service, but during, well,
when you're ascending to your orbit and deorbit. Why? Because let's say for OneWeb or Eutelsat group, our service altitude is at 1,200 kilometers, but the rocket injects us at 450 kilometers. So we basically need to orbit race until we find our service altitude. What is the issue, between commas, that between those altitudes, there are other constellations there. In this case, right now, it's Starlink, SpaceX, in the future, Kuiper, Telesat, Rivada, SSST, and CSCN. So we believe that there needs to be like 3 principles that everybody should be doing. And the first one is just basically knowing where your satellites are, where your satellites will be, and if they can move. So ephemeris is just a fancy word to say like where the satellites are and where they will be like in the short term. And this needs to be like transparent and needs to be like in a platform where they can do collision avoidance. They can check if the satellites will be like collisioning with other satellites for other constellations. So another key thing is, because you have all the satellites there, or the position of the satellites, to be able to assess if there is going to be a collision, a possible collision in the long term, in the short term. So, and then last, but actually like more important, let's say you received an alert that's saying, okay, operator A, satellite X, and operator B, satellite Y, they might have a collision in 4 days. And operator A is, you know, I'm such a nice guy, I'm going to move out of the way, I'm going to go up. But then operator B goes like, yeah, I'm such a nice guy as well, so I'm going to move out of the way, I'm going to go up. So the collision avoidance is still there. So it's very important to coordinate that movement to make sure like one moves and the other one stays. Super simple. So the space sustainability, this is currently it's being studied in ITU with resolution 74. They're developing a handbook, but also in COFOR and we need to be responsible, and we need to know like the space situational awareness, like where the satellites are and all this stuff, what I just said before. And then we need to be very transparent. This is nothing to do like where my satellites are, you know, it's we need to make sure like there will be like space for everybody in the future. So here's the question that I really want people to remember, especially administrations in these international meetings. How do we share ephemeris and plan maneuvers between international operators? Because right now we are using Eutelsat Group, Leo Labs, and SpaceTrack. For instance, Starlink, they're also using SpaceTrack, and we're using it to coordinate our constellations. But they're based in the US, of course, so we're super happy. But you know, this political thing between China, just putting a name there for whatever reason. So we need to make sure it's public and everything is there. So this is a key thing. And China, they're going to start launching at the end of this year. They're going to be very close to where Eutelsat Group has the constellation. And by the way, the picture on the left doesn't represent much. It just represents the Eutelsat Group constellation. But you see like loads of satellites moving. It looks like chaotic, but no, that's completely fine. It's just a representation. And if you're a bit more interested, just read about what we do in responsible space. And I'm sorry, I'm super trying to do it super quick. And this is on physical sharing. Now, just briefly on spectrum sharing, this is agenda item 1.2. It's on the KU uplink, on the user link. The Eutelsat Group is using 14 to 14.5 for this link. But there is also within the ITU an allocation between 13.75 to 14 for the FSS. However, there is this one is shared with RLS for allocation services on a primary basis and SRS on a secondary basis. So in order for FSS to use this band, there are like some limitations. For GSO, you need to use an antenna of 1.2 meters, and for non-GSO, a 4.5 meter. Just on there, like it's small, like not completely today, but you can see like the difference. So maybe a user link 4.5 is not very convenient to use. So why it's important, or why it's easier to use an adjacent band for the spectrum to increase it rather than use another completely different band? Well, because I'm not going to go super in detail, but I think it's very clear for everybody. You can use the same hardware, you just need like small changes, just tweaks or the tuning. So it's much easier to use the same what you've got rather than do a completely different receiver, antennas, and all this stuff. Then spectrum reuse, similar propagation characteristics, not going to change much from 250 megahertz to another 250 megahertz if you are like high up in the spectrum. Regulatory wise, it's going to be pretty much the same. In there. And then for smooth transition, because you're going to use kind of the same hardware, you don't need to turn on one thing, turn off another thing. So it's much easier. And then, well, just because of these things, it's going to decrease the amount of money that you need to put on the capital expenditure. But again, this is shared with RLS, so we need to make sure that they are protected because they're in a primary service. So the plan for the future for this WRC is to do the studies, which are already happening, like 4A just finished, and to ensure that reducing the number of the satellite antenna diameter on the 1375 to 14, it protects RLS and SRS. So if that's the case, and we'll see like in the next few years, then we'll need to change the regulatory adjustments necessary to be able to use it in the future. And I hope that was quick enough. And thank you very much. If you have any questions, happy to take them.
I think. Josh, last but not least,
There we go.
if you could bring us in for about half past, that would be
We'll go
fantastic.
quick. Josh Baggett with Hewlett Packard Enterprise. So in 2020, the US FCC opened up 6 gigahertz access for unlicensed use. Since that time, we've expanded to 76 countries in some form or fashion. In the US, we've seen $870 billion in economic value as a result of opening up this band, which I think is just pretty incredible. Globally, what we're seeing with the band is $4.3 trillion in economic value this year, $5 trillion going next year, in large part to 6 gigahertz devices, 800 million shipped, right? 270 million Wi-Fi 7 devices. That's what we're going forward. And then from the access point, what we're looking at is about 170 million Wi-Fi 6E and Wi-Fi 7 devices going out. From a Hewlett Packard Enterprise standpoint, it's really, we are all in. Customers are coming to us in droves. They're seeing what we can do with this in manufacturing, healthcare, education, and saying, please do this. And so we've made the decision to go all 6 gigahertz capable access points going forward. I think it's a pretty big deal. We're also doing standard power in the US under AFC. We are deploying in stadiums at this point, and it's honestly just kind of a really great thing to see what we're doing. The AFC obviously helps pick our channels, and that's why this slide is probably the most important. This is a to-scale slide of the channel availability in 2, 4, 5, and 6. And so you can see in the gold part, if you only do the lower half of the band, that's what we have available. And the important part of this really is if you look across the entire band, you can get 59 20 megahertz channels, 29 40 megahertz channels, which is where enterprise lives right now. 20 and 40 megahertz channels, that's our capacity, that's our constraint. What we go to, if you can get access to the entire band, 14 80 megahertz channels and 760 megahertz channels. That changes everything. Why? No channel interference. We have to avoid it. That's what you have to do in large, dense deployments. You have a ton of people. You have a lot of access points. They're all listening to each other. And the only way that we can get to 80 and 160 megahertz channels is with access to more than just the lower half. And it's just a fact. It's just where we live today. And that's really what gives us that higher throughput, network performance, and reduced airtime, which is why we advocate for all 1200 megahertz, because that's what, frankly, customers are coming and asking for now, because the use cases are here. We can do physical slicing, we can do virtual slicing in networks, create different use cases. So this is why we're going.
Josh, is the situation different in Europe? Like there's no demand, that's why we're looking at beer.
No, we have a lot of demand, and I'm putting together a document. We've had, and this is just funny how timing works out. This week I had a salesperson reach out, and he had 5 different customers in Europe who had come to him and said, we can't deploy, or we don't see the need to deploy if we can only deploy in 480 or 500 megahertz. And so the use cases are here, they're seeing it, they're asking us for it, and I can talk about that on a one-off basis. I don't think I can talk publicly about who the companies are yet. I'll have to find out, but happy to give you cards and we can talk about it if you want. But it's happening here, they're asking for it here, and the constraints are here.
And can you deploy today in the upper part, or you need to wait for some decision?
Here?
Yeah, I mean in Europe.
Oh, we have to wait. Yeah, they're not. That's what we're all arguing about. So I won't go through that because we don't need to. This last slide, there's really only two things. So this is the evolution of Wi-Fi 6E to Wi-Fi 7. I think the gentleman from the Ministry of Defense said it best when he was talking about going to 6G yesterday. This is an evolution, not a revolution. I mean, if you're looking at 320 megahertz channels, that's great. The QAM is great, but it's a 20% increase. But again, 20%, I think we were talking 20% exponentially earlier, maybe you too, and we can argue about that. But the theoretical peak data rates, 46 gigabits per second, that's huge, right? That is going to last us for a long, long time. And really the most important thing on this slide is a picture of an Aruba access point, because you won't see one up here for whatever reason, Prakash. So
we talk afterwards.
That's it.
It was my fault because I realised we moved on one presentation. There is one from Nada. I think let me.
Yeah, she has 4 minutes.
It's all testing.
I should use the female equality thing now.
Yeah, you should get the full like.
Women in engineering. That's right. Yeah. Absolutely, you stand your ground. There we. Okay.
Yes.
Thank you, Jack.
Thank you.
That was my fault because I know we moved one on.
It's okay.
Apologies.
No. Thank you.
My specific. Special.
Okay.
No. I want to duplicate screen.
Just get out the way.
Excellent.
Over to you.
Okay. Thank you and hello everyone. I am Nada Abdelhafez. I am responsible for the spectrum and regulatory affairs at Shure. I'm responsible for the Middle East, Africa and India, and I'm based in Dubai. So I'm very happy to be in our Shure office in London. Great that I had the chance to meet everyone. I remember my first visit to London, which was around like 10 years ago. So I went with my friends right after graduation, and at that time we made sure to pre-book a theater show, which was at the time The Lion King. I remember it very vividly because of the experience that I got to see. And to me, I had no expectations going in. I thought something like the cinema, but then I was surprised to see the performers coming right down next to me by the stairs. We didn't have enough money at the time, so we had to book like seats that are not too close to the stage, but still we had a very engaging experience. And at the time, I unfortunately, I don't have any images of it because I was not allowed to use my mobile phone. So mobiles were off the use. But still, I would want to, in the future, take my kids to the same show and hope that they would get to experience the same engaging experience that I did 10 years ago. And with that, of course, we need to have access to the audio PMSC spectrum. So we've heard a lot about this in the 2 days, so I hope I won't be taking a lot of time.
Yeah, you won't, it's not working.
Thank you. So I'll be very quick with this. As you know, there are a lot of events that are happening in the Middle East region where I'm from, and we always present to regulators the amount of spectrum that is needed to host all of these big events, starting with the Dubai Expo. You can see the thin white lines showing the audio links there. Similarly, in the World Cup in Qatar, and ending with Paris Olympics that NFR covered very well yesterday. While saying that, still we have shrinking spectrum access. We expect perhaps more bands from the UHF to disappear in the near future, or at least this is what Uli, my colleague, is hoping for. I remember as well in the very early meetings that we had with few regulators in my region, and while we're discussing the lack of spectrum access with the potential loss of the 600 band, we heard a very interesting response at the time. I think Prakash would remember that. And the response was very easy. if you need spectrum, we will switch off an IMT base station. At that time, we were shocked. We thought that the regulator did not take us very seriously. And then fast forward a few years later, the UK SPF commissioned a report proposing just that same suggestion or solution, but using more sophisticated terms. They have looked at PMSC usage and Ofcom licenses for a period of 1 year between October 21st and September 22nd. And they proposed a number of different solutions for different scenarios. So looking at this area here, West Yorkshire, I'm not sure if this is in London, Martin, or is it?
The bottom right one, and the other one is West Yorkshire is not in London.
It's in England, I have to correct that one.
No, that's good enough.
Yes, so they have categorized the spectrum needs based on the licenses. You can see these nice colored boxes where the red indicates we need more than or between 136 megahertz to 168. And then the orange one is 104 to 136 and so on. So, and then they analyzed the available spectrum in the different areas, including and taking into account the DTT channels, and then looking if or not 600 would be given to mobile or not. And they've also looked at the situation or the scenario to which where you would need that particular spectrum. So in the West Yorkshire, basically there's an event that would need between 136 megahertz that happens a couple of days a year, and versus the West End district here or area in London, where you can see it's pretty much crowded with 40 plus theaters, as Tumo mentioned the other day, and you have a heavy need and utilization of for PMSC spectrum. So in what they're proposing, basically, if you have an event in West Yorkshire that you need more spectrum, switch off IMT base station. If you have deployments in the UHF band, which is in a fancier term, temporary reallocation of spectrum. Whereas in such a crowded or heavily needed spectrum area in London, they're proposing to have IMT exclusion zones. Basically, don't put any IMT base station in the UHF band where there is a high demand for PMSC in the area. So this was published around WRC-23. And then we are seeing, as Shure, we're seeing it come to light with more regulators considering this option and actually analyzing and studying their geographical areas and establishing a geospatial sense of separation between the IMT areas and the PMSC protection areas, enforcing PMSC protection criteria. I don't see Alex in the room, but this is...
Yeah, he ran away.
Yeah. So this is not only a proposal or a study, but this is coming to life in Germany. As you know, or as Alex mentioned yesterday, that they are looking into reallocating to the lower band in the UHF for military, and that there's ongoing coordination studies that we as Shure are also involved in. So looking at it from the bigger picture, if we have military in the lower UHF, TV in the upper, IMT in the upper, TV in between, we're kind of squeezed in. Uli still wants to share the 470 part, which we don't really agree on, but let's talk maybe about sharing more around in the 600. And this is the graph that Prakash also was talking about in the US. So when we say we have access to spectrum between 470 to 608, that's not really that we have the full spectrum accessible. In Phoenix, Arizona, we only have 12 megahertz of spectrum. This, anything that you can see, any black boxes, this is what we can use. The rest we rely on special temporary authorizations to be able to access the band for the events, and this is not a long-term solution. This does not guarantee that we get the same spectrum in the next year for an annual event.
So, for example, the 600 megahertz, so if T-Mobile or Dish Network hasn't deployed in the 600 megahertz that they get, so we'll just go to the FCC, ask for a special, like Super Bowl happened in Phoenix with more than these two. Every single megahertz we get. Now, imagine there's another auction that takes place. Also, you know, when the upper part is gone, correct, to IMT, the black channel at the top is gone. And then some of the TV were repacked at the bottom, the the other PMSC channel could be gone. So then what? That's the thing, is like, it's more complicated than, it's IMT, but also I think the broadcasters. I think it's a complex situation, and everyone needs to, think about this. It's not just, one or the other.
So saying that, and I want to quickly refer to a spectrum sharing framework study that was jointly published by ETSI, Winforum, and Shure. We're looking at different sharing frameworks. We've also, Axel, my colleague, was responsible to look into different applications, potential applications for the implementing an appropriate spectrum sharing framework. And you can have a look at it. So in conclusion, I don't want to repeat most of the things that we mentioned these couple of days, but we need to identify or acknowledge that PMSC is an important service. It contributes to the socio-economy of a country, and that future consideration during spectrum planning needs to be considered for PMSC and its needs as well, perhaps dedicating certain amounts of spectrum in the future to ensure that PMSC continues. So without further ado, Martin, just right to the end.
Thank you. Thanks all. So I'm going to try and bring you all in at some point. There's quite a few of you, and we probably won't get through all the questions, but I'll try and group some questions together. So we've heard variously about a range of issues. I'd like to start with the upper six. So this is a piece of work within CPT. It doesn't look like things are going particularly well at the moment. I think it would be fair to say. So we've heard from PJ, who has a view about how this will end up. Are we going, is this hybrid sharing model feasible, or are we heading towards a situation where perhaps CBT or different administrations just decide who gets what and divide the band? Is this middle way really feasible? I'll pose it to you, Josh, and I'll bring Reza in afterwards.
I mean, I think it could be feasible, and we support hybrid sharing. So at HPE, from the Wi-Fi industry, we support it. Why? We share everywhere, right? That we are the secondary user wherever we are. So we're used to it. We do it in the US. We do it across the entire band. We know how to do it. We do it well. We share with IMT. It all comes down to power levels, and that's the disagreement where I feel like there's no budging coming from IMT at this point. And I get it to a certain extent. Macro cells are expensive, and you're going to have to put more in to get the coverage that you want to get. It's tough, but it's what's going to have to be done at this point. It's not to say technology won't change, but it's just we're at a bit of a stalemate right now. And my honest opinion is kind of like PJ's to a certain extent. I think it won't be actual sharing that we're going to see. I think it will be band splitting, which is not sharing again. And I think that will end up being the ultimate result, to be honest.
Same question to you, Reza.
Well, just to be clear, the work in CPT at the moment is a technical study of options for sharing. It's not a regulatory decision to be made in this work item. So we're at the early stages. And of course, ultimately, it's the administrations who decide on all these issues. Industry is there to provide information on technical feasibility, economic constraints, commercial constraints, etc. But what I would say is that both IMT and Wi-Fi are arguably the most important or successful, rather, say not important, successful wireless technologies, terrestrial wireless technologies, and they both deserve a regulatory roadmap, which allows the industry to plan ahead. So for me, what's important is that administrations in Europe, at RSPG level, at the European Commission level, at CPT, really figure out what their targets are for these two technologies and whether existing spectrum can achieve that, or if not, what additional spectrum is needed. Does IMT need, for its evolution towards 6G, would it need more spectrum? And if so, we know it hasn't been successful in so far in millimeter waves. mid-bands is the sweet spot. Where in mid-bands can we have spectrum for IMT to deliver advanced 5G and SIP 6G subsequently? For Wi-Fi, given what existing spectrum we have in 5 gigahertz and lower 6 gigahertz, to deliver the data rates that are needed, does Wi-Fi need the upper 6 gigahertz? What are the roles of other technologies like fiber to the room? Potentially, you can have a Wi-Fi access point installed in each room. That'll give you tens of gigabits of capacity per room. What's the role of that? What's the role of millimeter waves for Wi-Fi? Millimeter waves have been problematic for mobile because they're long range. For short range communications like RLANs, millimeter waves are ideal. What's the role of 60 gigahertz for? You can have 60 gigahertz base stations, Wi-Fi base stations per room, providing huge capacity per room. Light communications, etc. I think administrations really should sit down among themselves, think about roadmaps for the two technologies, because they both deserve to have a stable regulatory environment so that industry can invest.
Did you had
just one, I mean, just to add, and I do think it's important that you look at the broader ecosystem even beyond this, because Manuel, I think you said it yesterday that IMT makes up 70% of traffic is now indoors for IMT for mobile traffic, you said. But you have to look at truly the broader ecosystem of all connectivity, because mobile traffic is only 10% of all traffic. 90% of all traffic is fixed, and that ends up going over Wi-Fi. And so that's the capacity that we're looking at. We're not just looking at the offload that happens from mobile, even when they're indoors. We have the rest of everything else to contend with. And so it is broader than just this and this slice. There's more to the ecosystem, to the economic value than just the mobile portion of it.
Thank you. I want to discuss satellite for a minute, just to change things. So satellite for years, anyone was involved in WRC, it was clearly internationally defined rules because of the nature of the service and application. But I would say, and I don't mean this disrespectfully, it was kind of stable and dormant. And all of a sudden, we have a WRC cycle now that is many agenda items that focus on that area. And the question I had, I guess for both of you, but it was for Gökhan. I read Access Partnership's initial report on the future of smartphones, and there were two kind of authorization mechanisms. One was, I think you described it as by the book, which is going via the official WRC allocations for MSS and FSS. And then there was another one which we've seen more recently, which is kind of a light touch, I guess, piggybacking on back of terrestrial networks and maybe using Article 4.4, which is basically, as long as you don't cause interference, it's a sovereign right to allocate or authorize a service in a particular band. So my question is, did the piggybacking option evolve more as a response to the WRC cycle being fairly slow? Because the emergence via Starlink and characters like Elon Musk would seem to indicate that they can't wait for a 4 or sometimes 8-year cycle where an agenda item is proposed at one WRC, then discussed, and then you have the study cycle begin. So was that something that you think came about because the WRC cycle is slow and maybe it's not fit for purpose anymore?
I think that's a very good observation. This WRC cycle, we have a big number of satellite-related items. And very interestingly, normally it used to be the IMT folks who come after other people's spectrum. In this WRC cycle, there is an agenda item where satellite folks are trying to sneak into the IMT bands in band up 13. So it is interesting. And there is a reality that there are, every year, there are new players, new space actors entering into this space, entering into this area. And there's not enough spectrum for everyone. And sharing, yes, it's very important, but everyone wants their own spectrum for their own filings in the satellite world. So for AST Space Mobile, Link or Starlink, for direct-to-device Starlink, they had to be creative. They had to go after partnerships with mobile operators, etc. So I think in the sense of WRC cycles, I would not put all the blame on the cycle being or the WRC process being slow. There's a reason that we have all these study groups and studies, etc. But the reality is that this technology is evolving and there is a demand. It is from satellite operators, I mean, for spectrum. So they wanted to get their own solution as fast as they can. And that's why we are seeing all these regulatory examples. They are not waiting for the end of the study cycle. They are just adding the secondary allocations right now and trying to prove that it would work.
Thank you. I know you had his hand up, but I've got one question for Francisco, which your presentation was interesting to me because what you described was a very physical sharing scenario, and you know, the physical regulation of space. And I just wondered if there were, I mean, the ITUR concerns itself with radio regulation, but I mean, is there any? Do you think there's any improvement that can be made to the ITU regulatory process of satellite spectrum and orbits approval?
So even though like the ITU only focuses on radio regulations, the good thing is that brings all the countries together. So it's a good way forward to just share where the satellites are, just for the fact that if there's, you could do the coordination with the spectrum, and that is completely fine. But unless you have the platforms with the payloads there, there's nothing you can do. So yes, of course, it should be like, it could be improved, for instance, like doing a handbook of best practices, but the ITU cannot tell, because the space is for everybody, right? Nobody has the private part of the space. But if you're there, nobody will move you, right? For instance, we're at 1,200 kilometers. You can try to put another operator there, but that's physical, no coexistence. So two things that could be improved is the coordination between operators and the technology of the platforms. That means like the GPSs exactly know where you are, like, because right now in how it works, it works like as a box of the probability of where the satellite is. So you say like, and the lower you decrease the box, the more, you know, so basically you can have a box of, I'm making it up like 100 meters by 100 meters, and you think the satellite will be somewhere there. Or you can say like, no, I know exactly where it is. So it's going to be 10 by 10 meters. So it's easier, right? Because you win like more than 90 meters in one direction. So that is one thing. And the other one is the propulsion of the system. You need to make sure that if you're going to have a constellation, and this is one of the requirements, that your satellites will be able to move. So you can do not only orbit racing, but maneuvers. So the ITU is a great way of doing, but they cannot impose anything, but it was a good way of communicating with each other because there's already like an understanding already with regulation.
Did you want to comment, Eley?
Yeah, maybe to the earlier question, I think there is the motivation by the ecosystem. So there's a clear target to work with legacy handsets, which by definition are in bands assigned to IMT. So maybe Apple can afford an extra radio for a very specific service, differentiating into a device, but it's a very different target if you want to cover like rural Africa on cheap existing mobile devices. Well, then you just end up in those bands and question mutual agreements with operators, or do you need some ITU process, which we now have, well, under agenda item 113 or so, maybe also giving them an allocation for that. But MSS bands are typically by definition just not supported on handsets. And maybe to extend that thought, even PMSE looking into private 5G networks, not for professional audio, but for video production whatsoever. You want to join that 3GPP existing ecosystem in which then leads to the questions sharing or whatever, set asides or create for two. Yeah, so I think it very much boils down to this question: can you use those existing large-scale ecosystems to some extent? Can you build on them, or do you do something completely separate?
I've always had a problem with the term set-asides. I mean, it's just it just basically means that anything that's not allocated to mobile, in my view, which is it's just I find it a strange it's a strange kind of use of language. But right, so Manuel, I know we rushed through your presentation. We covered. You did a really good report on defence spectrum sharing earlier this year with UK SPF. But the question I've had is that LS Telcom provides technological solutions for regulators to use. So when regulators talk about sharing by design, how is LS Telcom responding to the likelihood of increasing demand for spectrum and where things seem to be going? I mean, as a business generally, I mean, how are you responding?
I mean, I think back in the day, we were involved in the TV white space database. I think we did stay away from it for a bit, but I think it is true that regulators do need to be more flexible now, and I think we are trying to respond to it. And one thing that hasn't really come out during this 2 days, which I'm a bit surprised, because I think it comes up in every other technology conference or workshop that we end up going to, which is the new technologies, whether it's AI or other new technologies, and how would that enable future sharing? I think it's also important to consider those, and will that help, and will that become an enabler? So I think from our perspective, it's just trying to respond to those flexibility needs of the regulators. I mean, we've seen that Ofcom with the share access licenses regime. I think now with the harmonization of the 3.8 to 4.2, more countries might adopt a similar approach. So it's just trying to move towards either directions, towards automation, towards the new technologies that can actually happen.
On that, there's a related question which is interesting, because part of the roadmap that they tend to set out is moving towards automation, so cutting down the lead times for licenses and authorizations in shared bands. So one of those things is that a model of spectrum regulation that looks like it's working relatively well, in my view, is this tweaking, this test and adjust. So as a business, does that require you to be more nimble in response? Because those adjustments might come around a little bit more frequently than they otherwise would.
Yes, and I think it's also, I mean, I think that the data as well and how that data is treated, I think it's quite important. And I think that similar to what Francisco was saying, I mean, the more granular data that you have, the more flexible and the more sharing that you might be able to do, either whether it's a spectrum or more on a physical level. So I think that it is important to have that data. I mean, I think that there's also a set of concerns or set of questions that come with the more data you have and how you treat that data and what is the relation to the stakeholders. But I think it's certain that there's a requirement to remain more flexible and to be able to adjust. And I think that we've seen this across the different clients that we have around the world.
So my next question is to PJ.
Oh.
So I think your presentation earlier on the data CBRS by numbers was particularly enlightening. So in terms of the decision by the FCC in collaboration with other agencies to reduce some of the conservatism in that model, I mean, how big a decision was that? And what are the end results to users? How is it being felt by your end users?
So, okay, first of all, I think the FCC did not really have I mean, the decision to relax the protection toward the incumbent was rather coming from the federal and the NTIA. The FCC was rather in they watch this rather than being proactive. We were able to do that, so the CBRS.0, that we relaxed the protection threshold because of the data that we collected. So we started, the first step was something very conservative, but we were lucky enough to have those data at hand and being able to review those data over the years. And at some point, because this works only if there is a trust, right? And the trust comes with facts, with data, not because we like you or you look nice, right? So again, this is a very good example of we were able to really change the game because we were able to produce facts about how the network, how CBRS, when it scale up, was behaving against the incumbents. And yes, I mean, it was provided with data. Now, just coming back, we did not touch the AI stuff. CBRS, I mean, the trust in CBRS today is because this is a very deterministic outcome. Everybody with the same set of data comes to the same result. We are not yet about AI, right? I think it's the completely opposite. I mean, in CBRS, we have to have those deterministics algorithm we are certified against. And the DoD knows that if you have these things coming, the result will be the same for everybody. So we are not yet touching the AI, but now we can use AI on the amount of data we have for other consideration, like for managing the coexistence between the commercial system. So I think we are thinking about AI. But again, CBRS is good because we have a ton of data that we can build on. And we have to start somewhere. And we started 5 years ago. And the good thing with CBRS 2.0 is the proof that you set a rule, you set rules, and we were able to evolve from those rules. We were really, so CBRS is agile. Wow. Yes, it's agile. It has been proven. And one more thing about complexity, I now disagree. I changed my mind over years because we built CBRS. I think regulators should stop saying that complexity is the barrier. CBRS is complex, but it works. If you can just make sure that that complexity stays, and it's not necessarily something that prevents the ecosystem to grow, complexity is acceptable. CBRS is complex, and I think it's acceptable. So yeah, thank you.
Right, Simon. What? So we heard from you about use of video PMSC, wireless cameras in the combination. So in terms of technological and regulatory barriers, which barriers still exist to the broader use of 5G private networks, but specifically for content capture and distribution? So that they could be on the administrative side, on the technological side. So the shared access consultation recently, I know it's still open for consultation. So with respect to Ofcom, decision hasn't been published in a statement, but you are an end user. That band was very attractive, or is very attractive to you. There's silicon in the band for use. What are your views?
Well, in using COTS hardware, generally limited to the new radio bands, so sharing with IMT. That is evolving. There are software-defined radio systems, we're told, and we can operate in other bands as well. And potentially that would be good to operate in ranges which are currently available for coffin wireless cameras. That's been done a little bit. And we'll be doing some trials in Scotland, 40 band, shortly. In terms of the 3.84.2, which has been very vigorously adopted in CPT, and the EBU supporting that, and submitting a very supportive paper on that. I come back to the short notice, short-term access, which is not yet fully addressed, certainly not in the UK. Christina talked about swifter access, but they've been very clear that shared access licensing, which is the current model in the UK, is not for pop-up networks. And we take that to mean
you pretty much describe PMSC.
So that is the current challenge, I would say, and that's why I was particularly encouraged to learn so much more about CBRS today. In that a more dynamic, automated system that is clearly working in the States would be a really attractive way to manage that spectrum with so many different applications in there, rather than the sorts of discussions to be going on in the consultations, which are around coordination distances, and maybe we can assume synchronization,
medium power,
but not imply it. Maybe stretch the power a little. I think an automated system which is as radical as CBRS is a better way. It still seems, I mean, when I was applying for the licenses for Coronation, we went through a number of iterations, and it seemed to be that it was going to different parts of Ofcom. Oh, by the way, we need to consider this, and oh, you can't have that band. And then later, oh, there might be an embassy with C-band down. We were left right up to the last minute with me having to use credit cards, sat in a porter cabin with very little connectivity to buy licenses at the last minute. That's apart from the PMSE model in PMSE bands that Ofcom has, which is pretty much untouched since before 2012. Is that correct? Would you agree with that?
The video side.
Well, all PMSE online applications. Yes, there is short-term applications for that.
Yeah, it has been left untouched, but in fairness, so I think so are the prices. So.
That's true. Yes, it's gone from it's gone £8 to £8.50, but 48 hours. That the current sharing in 3842 has not been considered for PMSE currently.
Okay, and we've discussed dynamic spectrum access, use of databases, NADA. The spectrum sharing frameworks for temporary, dynamic and flexible spectrum access. We've heard a lot about those systems and potential capabilities. They all look interesting. Could it be applied to PMSE?
Well, PMSE is the ideal application, as we've discussed throughout the past couple of days. But then it would depend on how you adopt the particular sharing framework. There are certain things that you need to keep in mind, including not impacting the quality of the service of the PMSE, the audio PMSE device. And you need to put in certain, again, the regulator needs to put in the framework for this in terms of managing whether or not you have a primary or secondary, who gets what on what basis, and ensuring that you have if it's a database based, well, let's say a spectrum manager entity that takes a decision based on the database, the regulator needs to have that information available, and it needs to be properly maintained. So there are different factors, but definitely the regulator and the stakeholders need to be aware of, plus the readiness, again, of the devices, whether or not they'll be somehow integrated with this, this spectrum manager tool that would make all of these decisions. But in the future, we see that PMSE would be an ideal application that would fit perfectly in this sharing framework model.
And Ulrich, last question, I think, and are we okay with time, or should we bring in audience questions, or should we keep going?
The audience has questions.
I've got one for Eley though. Final question, and we'll open it up to the room. So I hear about sharing by design for 6G, and we hear about network of networks and all this sort of stuff. Christina yesterday said no one knows really what it is. I think we saw the same back in the early days of 5G and the various use cases that would come out, none of which really came to fruition. Is sharing by design being considered seriously in 3GPP? And typically 3GPP doesn't investigate sharing with other services. So what role can 3GPP play in this, and what role can regulators play in sharing?
Yeah, I guess that's a tricky one.
So yeah, well, that's why we're here.
And let's say the formal answer certainly is that there is no 6G standardization ongoing by now. They only will start, so they're not looking into designing the sharing into that at this point in time. Certainly major players like ourselves, we definitely look into these sharing possibilities. 3GPP then has a specific scope, as also outlined in the question, so it's not really in their scope looking into other services. So definitely something to be discussed, how well the interworking between the different parties can work there. Yeah, sorry.
No.
Be more, so
It's
that's an open question, I guess, to the entire industry, but not only the mobile industry, but also those players who intend to share with whatever sharing then means. Yeah, is it geographical sharing, or is it really by the millisecond in some decisions?
I'm going to go to Reza first, and then we'll come back to.
Sorry, I just want to make a comment. Sharing by design is one of those terms which I find really unhelpful.
I didn't coin it.
Whoever coined it,
The White House, Ofcom.
first of all, probably didn't understand anything about spectrum management and spectrum engineering. But it's one of those terms that doesn't help. Spectrum sharing by design, sharing with whom, and at what granularity.
In
What does it
dimension?
mean? And what does it mean? And 3GPP should go and do sharing by design. Sorry, that's such a meaningless. We need to be much more specific. The one example of sharing by design, which I think everyone knows about, is ultra wideband. Ultra wideband was designed as an underlay technology, not to cause interference to others and to accept operation, non-interference, non-protected. But it uses spectrum really inefficiently. So there is a trade-off. Engineering is about trade-off. If you want to be sharing with everything, then you have to accept that you have to use spectrum inefficiently. In terms of ultra wideband, you use pulses, you use time very sparsely. So you're using spectrum inefficiently. That's not a bad thing, because the benefit is that you can share. So it would be really useful for everyone to understand that there's a trade-off, and just to say sharing by design, that's not necessarily that has implications. So I'll stop there. My rant.
My apologies for triggering you.
Thank you. It's one of those red buttons.
No. That's okay. We'll go to the room now. So if anyone's got any questions for the panel, there was loads of interesting stuff in there. Come on. No? Otherwise.
No, I do have a question, which is, I think that it's been talked about today a little bit, that Europe could embrace a more dynamic spectrum sharing, whether it's database or other. And just thinking about that, I mean, we heard this morning that CBRS was pretty much championed by Verizon. There was a lot of interest to make it work.
Yeah.
My question is, if
Verizon embraced it, but
I know,
it was not the champion.
Come on.
No, okay,
but my question is, if Europe were to
on.
move in that direction, who is going to pay for it? What are going to be the financial implications?
I think the main difference between Europe and at the end of the day, it's about lobbying, right? It's who is lobbying the regulators, who is lobbying the policymakers. In US, when you have Google, when you have HP, when you have Meta, that balance somehow Verizon and TNT, you may have something which is more balanced. In Europe, up to now, is really much, or it was MNOs that were able to lobby stronger those policymakers. So I think the state of play in US, coming with CBRS, which has been promoted a lot by Google.
Yeah, but these are global companies, correct? HP, I'm sure they want to sell in, Wi-Fi 6 here too.
No, but he's not wrong. I mean, it's something that I've seen coming to HP, is that we don't lobby globally as well as we do in the US. In the US, the Wi-Fi unlicensed industry is strong. We've been strong. We've been doing it since 2016 as a coalition. I was at Cisco at the time when this first started. And it's a group, it's a solid group. And yes, we've grown globally, but we don't travel quite as well as a group. And we were talking about it last night, even going to WRC, we sent 14 people as a full industry. Satellite sent, 40 something or 50 something just as satellite. Yeah. I mean, it's a few companies, and we have all of these big US companies. So PJ is actually right with this, is that you've got to be there, you've got to be present, you've got to be at these things to talk. And we just haven't been in Europe as well as I think we should have.
And maybe to conclude, I mean, that's what I was talking about when I was talking about PMSC. I think that's what's missing also for the PMSC industry. Like, we don't have a group of people doing what you guys did with Wi-Fi. I remember the battle with AT&T, Verizon, and T-Mobile, correct? And actually Wi-Fi 1.2 gigahertz of spectrum to Wi-Fi. It was, it was something that other industry can maybe inspire themselves, or can use as an example and try to mimic, maybe, to some extent, obviously, as you said, Meta, I mean, and all these companies. I don't think necessarily that you can have a same leverage as these companies, but you know, it's something we can look into. The thing I would say, there was a question I think about dynamic spectrum access. So Nada had a slide in there about some of the work happening, you know, that we did in SC with WindForm actually, to try to adapt the CBRS framework and the FC framework for use in Europe, irrespective of the band, correct? I don't like to mention 3.8, otherwise I'm going to trigger PJ there. But you know, it was something we put forward, and I can tell you the same thing. You know, it's on paper, it's there. But when we talk to Ofcom, you talk to Binetza or NFR, there's no interest whatsoever to even look into that. So you know, we spent, I don't know, a year, I don't know, six months with WindForm.
Yeah.
Because all the complaints or criticism of CBRS, we took that into account, and we tried to strip, you know, that framework out of the complexity. PJ, please don't get triggered again. But that was the argument that regulators in Europe were making, and we did everything, spent time, and it's just sitting in a report. So you know, there's something out there that could be used, but there's no interest whatsoever in Europe to even look at it. So anyway, thank you everyone for attending, and Martin, thanks for being the master of ceremony. And yeah.
I hope you all enjoyed it, and I know some of you came a very, very long way, Josh and others. So my great appreciation, and we were aiming to get a balance of views, some frank discussion of opinion, and I think we got there. So hopefully everyone from all sectors and all users took something away from this. So thank you very much.
Thank you.